Thank you for staying and for waiting. This was completely unexpected, on script, not on purpose. Anyway, so you're here because you want to hear more about Gradle. And I suppose that most of you use Gradle already in one way or another. Am I right? Yes? Anybody here not using Gradle? Awesome. Perfect. My goal is for you guys to feel like this whenever you are building with Gradle. Gradle is an awesome tool, but it has some issues from time to time. Just like any other regular tool, there are no silver bullets, there are no magic tools, so we always have to be aware. Okay, so quickly, okay, more things failing. All right, let's do it the old-fashioned way, okay? I promise the next time I have problems with the slides, I'm going to just draw on paper and just show it like that. Okay, so my name is Almiray. I come from Mexico, so I could be speaking Spanish, but we have members in the audience that come from other places that do not know Spanish, or maybe you do. But I work for this company called Canoe, based in Switzerland. We do lots of interesting stuff with Java and Groovy. And based on the experiences that we have had with our customers, with our internal projects, is where I draw from those experiences and come to you here to talk about the things that we have learned and things that we have suffered so that you don't have to go through those pains. I'm a member of the Groovy development team since 2007. I'm one of the founding members of the Griffon framework. You might have heard of this crazy framework that is used for creating desktop applications. Yes, there are still people writing desktop apps. It's not all mobile, and it's not all web. So yeah, JavaFX and Swing still working. Anyway, so let's get started quickly. How do you install Gradle on your system? I love this audience already. Because who in his sane mind downloads a zip file, configures a path environment, and checks that everything is working, right? And continues to do so in every new release of the tool? That's silly. So, if there's somebody still that hasn't been using SDK man, just do yourself a favor and do this. Download SDK and then just install the latest Gradle. And you can switch with different versions of Gradle depending of if you want to use a very old version or not the latest one, especially if you're testing out release candidates. Okay, so that was a doozy. That was easy. How do you initialize a Gradle project? You have seen the slides already? Okay, one said Gradle init. Good. And somebody else said? Yeah, exactly. So, of course, the first thing to actually know is not Gradle init. What we do is exactly the same way as we do it in Ant and Maven. We copy from an existing project, modify everything, and then pray that it's going to work. No. The Gradle tool allows you to do this thing called Gradle init, which will create a settings.gradle file, a build.gradle, the Gradle wrapper, and not exactly sure if we will create a Gradle.properties files too. The thing is that it gives you just the basic skeleton of how a simple Java-based project will work. The great thing about Gradle is that you can build projects that are not only Java, but it could be, of course, Groovy, or could be documentation with AsciiDoc, or something that is completely unrelated to Java. So Gradle init works just for a small set of projects, just Java projects. The great thing about Gradle init, though, is that if you have a Maven project, you can convert it to Gradle, but just by calling Gradle init at the root level of the project, and this will generate all the Gradle files for each project, if it happens to be a multi-project build also. Now, be aware that invoking Gradle init on a multi-project or just a regular Maven project will only migrate the dependencies. It will not migrate plugins because it's impossible to determine what is the matching plugin from Maven into the matching plugin in Gradle. And one thing that I don't like much about migrating this in an automatic way is that when Gradle init generates the build files, it uses the long notation for the dependencies. I hate that. I really like to use the short one. I guess the reason they do it is because you may have classifiers or some additional metadata in a dependency, which is, we can define that in the short form, and this was, for some reason they went with the long one. Long story short, Very easy and quick to migrate from Maven to Gradle, but you still have to decide and find what will be the matching plugin from the Maven world into the Gradle one. Let's give it another go. Or what you can do is use Lazybones. Now, Lazybones is a project bootstrapper project. Well, quite a mouthful. The basic idea is that, if I'm not mistaken, Peter Ledbrook, the creator of the project, asked Luke Daly for a way to bootstrap new Ratpack projects. And in the time, we already had Grails and Grails Create App and Griffon Create App and whatnot. Ratpack said, no, we're not going to go down that route. We don't want that for whatever reason. And so Peter was very frustrated and said, well, yeah, okay, so I'm going to roll down the sleeves. I'm going to create a new project that will allow me to bootstrap Ratpack projects. And besides that, he said, well, if I do this for Ratpack, fine, but what if I will be able to do it for other projects as well? And that's exactly what Lazybones is. In rough terms, think of Lazybones as Maven archetypes without the Maven socket. It does work. Now, there's one added benefit of Lazybones, which is that Maven archetypes do not have. So once you initialize a project, the archetype is gone. You don't need it because you just created the project. But what if you needed to create additional artifacts? So those of you who have used Grails in the past, or if you used Griffon 1 in the past also, you know you can create new artifacts such as controllers and views or model, domains, classes, and whatnot. A Maven archetype would not help in this case. But Lazybones has the concept of sub-templates. So there is some relationship that still lingers with the Lazybones template that allows you to create the project and the project itself. So you can create new artifacts as you go. I think I have an example here. Let's see it. The terminal, hopefully, yeah. Let's make this a little bigger. Much bigger. And I noticed that I really... yeah. So here we go. I'm going to initialize a project. Much bigger. There we go. Lazybones. Create. I'm going to create a Griffon JavaFX Groovy, because we're in a Groovy conference. Project. Like an archetype, it will ask me some questions. Oh, come on, I don't have the latest version. I don't have network, so I know that the latest version is the one that I'm currently working on. Should be this one. Okay, so it will ask me some questions, and I'm going to accept all the defaults. Perfect. Going to that one, and if I look at the project now, can I do this? Yeah. So the whole project has been initialized, and we got controllers and views and models and whatnot. Now here's the sample controller. So the feature that I want to showcase is the generators. So I can say Lazybones generate the name of the subtemplate. I know for a fact is artifact, and I'm going to generate an MVC group. This will ask me some questions, and it remembers where were the settings in the beginning. For example, org example. So I'm going to accept that, and I'm going to say something like Greach. These will generate additional files that if we go back here, you can see there's the Greach controller, and maybe they will see the view, the Greach view, and whatnot. And these things have been initialized using the default template for views, using GroovyFX, and be happy. So in this way, you can keep generating artifacts for a particular project, even though well, archetypes will not allow you to do this. This is perhaps the second reason why I would say use Lazybones. We use it with our customers. We have encountered places where we need to bootstrap a series of multi-project builds that follow the same pattern. So we created a Lazybones template for that, and just starting a new project is a breeze. Okay. The next recommendation that I have for you is definitely fix the Gradle version that you're going to use. Always do this. And the easiest way to do it is use the Gradle wrapper. So the Gradle wrapper allows you to set the particular version number for Gradle that you want to use for that project. Now, I'm really happy that the Gradle wrapper is a very early feature of the tool. because I had a project back in the day, I think this was more than 5 years ago, when we were still in Gradle 0.7. Let me count, no, it has to be 6 years ago. And I had the wrapper for this particular project. So I ran the tool, I ran the build, and the build worked perfectly well, no problems. If I were to run this with the latest Gradle, it would be completely broken because the build file is completely, it wasn't compatible. Okay, so this is such a great feature that the Maven tool has copied it over. Now they also have a Maven wrapper. You can provide a different distribution of the Gradle wrapper. You can use the default one, or you can set up one in your organization. What would be the advantage of doing that? If you have additional scripts or plugins, or do you change the dependencies for one reason, you can always go to that particular version instead of always customizing somewhere else. Finally, if you're using an IDE, and hopefully you're using one of the best IDEs, IntelliJ, you can set the wrapper URL to -all instead of -bin. This will download both the binaries and the sources. So if you happen to be a plugin author, or for some reason you need to get into the internals of the Gradle API, you will have access to everything, and you will be able to do proper debugging and everything else. Next one, invoking Gradle anywhere in your project. So who's using Gradle in a multi-project build? And you have the wrapper, I suppose, right? So you're inside one of the submodules, which may be 1 level, 2, 3, as many levels deep. How do you build this project, the submodule one? You go out and build the full path, or use the command line path, or you do .. / and you have to count how many levels you are. It's a little bit troublesome, isn't it? Wouldn't it be better if there were a way for you to run Gradle anywhere inside your project? Yeah, I think so. I would recommend you to have a look at GDub. GDub is a simple script that is able to locate both the Gradle wrapper or the Gradle that you have locally installed, if you have it. Now, I know it's a little bit silly that it's a script that invokes a script in order to run the tool, but it works. So let me show you how it works, and I can do it here on the Griffle build. I'm going to use the Griffle build as my battle horse, and make it a little bit bigger, perhaps. Is it visible? Okay. So I'm at the root of the Griffle build, right there. I'm going to go into, let's say, Griffon core. And so if I want to invoke the Gradle wrapper, I will have to do this. Gradle W, and then, I know Marcin, forgive me, I'm going to do a clean. And this will clean this project. No, it's going to clean everything, because I didn't specify the subpath for this particular project. Okay, so I could do Griffon core like this, but then I would still have to use the double dot notation. So what if I were to do something like this? Notice that there is there was a text at the top. I'm going to put it again. That says, using Gradle at this location, so that is the wrapper that it found, that's the wrapper at the root level, and I'm invoking this particular file. Now there's one particular issue that I have with GDub, is that it's hard-coded to match build.gradle. And this will get in conflict with the next tip that I'm going to showcase, because this project doesn't have a build.gradle file. It has a griffoncore.gradle file. But even if I do this with GW, say GW griffoncore classes and compiles, yep. Then I can go into even the build file, even the build directory, like I don't know, let's go into classes main, and I can do some Java P Griffon core, what is it there? I don't know, maybe do something inside that, and go back and do the same thing again. It doesn't matter where I am. I can go into source main Java, very deep, right? So there I am, very deep in the project, and then invoke classes again. It works. So quite simple to use. If the wrapper is not found, it will try to use whatever Gradle version you have in your system. And if there is no such thing as Gradle, then of course the build is going to fail because there's no possibility to build Gradle out of the thin air. How are we doing so far? So good? Okay, so multi-project setup. So some of you said that you're using multi-projects with Gradle. That's great. And one thing that I would suggest is to change the build file names, because I know that the IDE, when you open a build.gradle file, can tell you what is the logical name of the module. But if you're using a regular text editor like VI, the best editor that exists, it doesn't matter whatever you guys said, it is the best one, then you have to touch build.gradle file anywhere. And how can you tell which build.gradle file are you editing? And what if you happen to use TextMate or some other simple text editor that doesn't transform the name of the tab to the right project? So we'll be in problems trying to edit the build.gradle file that is not supposed to be edited to begin with. But if we change the name of the build file, then that's no longer a problem. But it's not just a matter of saying, oh, I'm going to rename the file and that's it. No, you still have to tell Gradle how to find that. And you can use a naming convention to make it happen. So my suggestion is that first you rename build.gradle file from your subprojects into the name of the project, .gradle, and then you add additional code in settings.gradle, because if you guys didn't know, settings.gradle is a regular Groovy script. Being a Groovy script, you can do anything you need or you want with Groovy, such as this. Say, for example, that your multi-project build is comprised of different directories such as common, full, light. And inside each one of these directories, on the second level, you have the actual projects. For example, UI common, core, model, whatever it is. So I'm going to iterate over all the first level directories, trying to find the names of the second level directories, which is this one right here, and see if there is a build.gradle file, well actually a project name.gradle file that matches. If that is the case, then I know that that particular subdirectory is a Gradle project. So I'm going to include it just like that. Now, what is the advantage of doing this? That if you want to add a new subproject to the common directory, then simply follow the naming convention. Create a new directory with name foo. Inside foo, you put foo.gradle, and then just rebuild. You're done. There's nothing else you need to configure. This will work automatically in the IDE as well. And you got foo.gradle instead of build.gradle. Here's another thing that we do. So it's not just the fact that the first was to include it, and this one is the actually that will try to pass the name, because we have a combination of a name / the actual name of the build file. So what we actually have to do here is these two things: making sure that we have the right project dir and making sure that we have set the right build file name. The last two things are just assertions to figure out. So if we had a full directory and we make a foo1.gradle file, the build will fail immediately because it's not found, it hasn't found the foo.gradle file that we're expecting. Again, as I said, being Groovy code, you can put anything you want there. Furthermore, how long are your build files in average? Very long? Very short? Too long. Exactly. Let me tell you what build.gradle file is not. Which is longer, this or the end credits of Long Wind the Wind? Right? So definitely, if you see a build.gradle file that is too big, and by too big it might be, I don't know, 400 lines or so, that's a smell. Something is wrong here. Try to keep it dry. embrace the power of conventions. That's the whole point to having conventions. So if you follow Maven conventions, everything has to be in source main Java, source main test, source test Java, source test resources, source main resources, well, blah, yada, yada. You know it by heart. If for some reason you have to use different conventions, then find a way to specify those conventions into a plugin or a script so that you have to put them again explicitly on the build file. The next one is the build file should be define how the project deviates from the convention. So what's the point of repeating yourself if the convention is already specified? So does anybody set source main Java in the source sets? That's not the point. And finally, you can rely on secondary scripts. I know this is a little bit of putting the problem into a different space because your build file is 500 lines long. And now you had transformed a 500 lines long file into maybe just 20, but you still have 500 lines. They are just in different scripts. The advantage of doing this is that some of those lines are grouped by responsibility. Some of those settings have to do with code quality, setting, for example, code narc or check style, PMD, the license plugin. They can go into a separate file. If you have configuring code coverage using Jacoco, Cobertura, or something else, it can go into a different file, right? You can define tasks inside the same build file. You can define anonymous tasks as you will. You can create new classes that extend or implement the task API from Gradle. But that will make your build file longer and longer and longer. What you can do is put these definitions into a separate script, or you can go one more level, which is use build source, which I believe might go away in Gradle 4, I think, or Gradle 5. I think that's the idea, to get rid of this thing. So use it or lose it while you can. Or the best possible solution is that if you need this behavior to be reusable across different projects, then create a plugin. Create a plugin project. And it's as easy as that. Applying plugins, there are two ways to do things. You can go old school or you can go new school. The old school is using the build script syntax. The reason why I prefer this one is that I can tell exactly from which repository it gets downloaded, which additional dependencies are needed for the class path, not just for the plugin. And I can do exclusions on dependencies, and I can apply the plugin exactly where it needs to be applied. This advantage is that it's very verbose, and you have to know all the little details. If you use the plugins block, on the other hand, then you know for a fact that the plugins must be downloaded from a single location, which is the standard Gradle plugin portal. If it's not available on that portal, then it doesn't exist for the sake of the plugins block. Another thing that is nice about the plugins block, if you're working in a single project, is that the definition says I'm going to use that plugin and it's going to apply it immediately for that project. But in a multi-project build, you may want to define a common place for all plugins to be located, but you don't want that plugin to be applied immediately. So you have to use either the old school syntax, or you use an additional setting called apply column false, which defines the plugin, does not apply it, and you still have to use the old school apply syntax on the right place that you need to put the plugin. So it's a combination. I prefer, again, the old school one because it gives me a lot of freedom, and I'm very pedantic on how I like my build scripts to be done. That's pretty much the reason. Next one. Don't reinvent the wheel. Do you have any idea how many Git-based plugins for Gradle exist? To just read the last hash or the last commit? Have you any idea how many different plugins exist to figure out what is the latest version of a dependency? I have no idea why, but there are more than one, and that's crazy. Anyway, the best place for you to find a particular plugin for Gradle is go into the official Gradle plugin portal. Many plugins are found there, but not all of them. So you will still have to do a Google search. You may find the sources on GitHub. That's the most common place to find them. And some plugins don't even have a release. But there are ways to get around that problem. Some useful plugins, these plugins are pretty much in every single project that I work on. I'm going to show some examples of that one. The first one is the versions plugin, and I'm using the new syntax that goes with the plugins block. The versions plugin will tell you what are the latest versions for a particular dependency. It might be a plugin dependency, or it might be a project dependency. And it only tells you the versions. You will be responsible for migrating to that version if you need it. The license plugin, this has double duty. One of them is to allow to format the file headers to conform to a particular template. And the second one is to generate a report of all the compile and runtime dependencies based on their licenses. So if you ever had to work with a customer that says, I don't want to depend on any GPL dependency at all, how would you tell? Well, if you apply the license plugin and simply run, I think it's called dependency report, no, download licenses, Gradle download licenses, and this will generate a report for you in HTML and XML, and so you can do anything you want to with this report and make it happy, make it beautiful. And finally, the versioning plugin. I said there are many plugins that deal with how to get the latest commit or hash from Git. Versioning works for Git and Subversion and a few others. And it's not just for the hash or the commit, but all kind of information that is coming from SCM. And versioning is the most, the better of the bunch. Now, let me see if I have a network. Will the network work? Let's give it a quick try. If it doesn't work, we'll see. So what I want to show is that with the versions plugin, it will give you a report of what is the current state of your dependencies, which dependencies are up to date, which are perhaps newer, you are working with latest snapshots or milestones, and which ones are of course outdated. But you can also configure the plugins in such a way that you can filter out certain versions. For example, by default it will filter out snapshots. But if you want to filter out release candidates for some reason, or alphas or beta versions, then you can also do so. No, it didn't work. Okay, so let's continue. Luckily, I was prepared for this one. So this is how you can do it. Actually, I copied and pasted this from the plugins documentation. It's just like that. Basically, what this thing is doing, you apply the plugin and then iterate over all the dependencies and do a regular expression on the artifact name. So if any of these things are found in the qualifier of the version number, then you simply are going to reject that. And so when you generate the report, this will not appear. So for a fact, I wanted to show, on the Griffon build, I have a Spock. The latest official stable release of a Spock is 1.0 Groovy 2.4. But there has been a 1.1 Groovy 2.4 RC3, I believe. And I don't want to see RC releases. So with this code right here, when I run it on my Griffon build, I don't see that particular version of a Spock as a possible candidate for upgrade. Next one, if your build starts to grow and grow and grow, then you're going to have lots of dependencies. And my suggestion is to keep all the dependency versions in one location. And this location, the one that I like to use, is Gradle.properties. Because if you apply the versions plugin and then you determine, oh, I want to upgrade that particular version, but I need to touch this file and that file and that file, and oh, I forgot another one, then if you use version, project properties like this ones, you know there is only one place where you need to locate them. So you define it in one place and then consume it on any other Gradle file, just like this. Use a Groovy expression, a Groovy syntax like that, and boom, you're in business. There's nothing else to do. It keeps things very clean. And it also gives you the capability, in case that you actually need it for some reason, you can define the Gradle version and the command line, something like Gradle W -P, the name of the, in this case, for example, let's see, Yukito version equals something, and then you can override that just for testing instead of changing the file. Another thing is that if you're doing this, if you are working with many dependencies, you eventually need to care about dependency version convergence. You might be consuming, for example, Google Guava version 19 from one set of dependencies, but you get 20 coming from the transitive dependencies from another place. So when you package, depending on how you package, you might get 2 different Guava jars in the final package, or you might get 20, or you might get 19. And if in this case, it's not so bad that you have 2 different versions of Guava. But there are other libraries where they are very, very sensitive to the different versions, the releases. So you might end up with binary incompatibilities. How can we fix this? Well, you can force dependencies. One way to do this is set the resolution strategy force to that particular version. Again, another reason to put those version numbers into a single location. And the second thing you do is this. If there happens to be 2 different versions for a particular dependency, you want your build to fail immediately. And it will tell you Guava 20 and Guava 19, fix this. It won't tell you which project, which dependency. So for that, the thing, I didn't show it here. You can run Gradle dependencies on a project that you might think it has a problem. And then you can figure out, oh yes, definitely, here's the Guava version or the other dependency that was causing me trouble. And then what you need to do to fix this is just add an exclusions clause to the particular dependency. And that's it.
You can also use dependency insight if you are looking for a particular module. So instead of running the whole report, you can do dependency insight. And then I don't remember what the switches are, but you can pass in what module you are looking for, and it will tell you that module, what is it pulling through, what's our dependencies, what's transitive dependency that module is off.
Okay. So for the sake of the recording, what Marcin is saying is that you can use a Gradle dependency insight to figure out what module has the problematic dependency that the report gave you. Perfect. Thank you. You can also supply additional information for developers. I really like to do this as well. So when you generate your artifact or artifacts, do you include the version number on the file name? Have you seen people that like to use the same version name, which means just the name and no versions, because they are lazy and they say, oh, here's a new release. There it goes, right? But you know which version it is. So what do we do? Yes, of course, you can change the name. I think it'd be better if you change the name. We can also give additional metadata. And the right place to do this is the manifest. And it's easy to customize the manifest entries for the jar in Gradle. And one way that I would suggest is at least these ones. You can add any custom entries as you want. For example, who built the artifact? At what, using which JDK release? At what time and what date? If you use the ISO, 8601 format, I would recommend you to do so. And here is my pal, the versioning plugin that will give me the latest hash for that particular thingy. And then something else. So if I run this thing in the Griffon build, let's see. Let's go here. Whoa. Let's go there. As a matter of fact, it wouldn't matter if I did that, right? Because I had GW. So I do Griffon core and generate the jar. And that's fast, perfect. And then going to subprojects, Griffon core, build TMP jar manifest, and I get this, and I get the latest hash. And because it's information that is already found in the manifest, you can have your applications reading this file, and this is something that we do on a Griffon application. So when you bootstrap it, oh wait a second, why did I change? Here we go. Let's go back here, and it was sample, right? So we do run of this Griffon project, which happens to be a Gradle project, and what? Null pointer. Whoa, not cool. Let's use another one. Let's use the Griffon examples, and this will be persistent address book, and then let's run It's address book, and just because we are friendly to a Spring, don't we? Somehow. Let's run a Griffin app using a Spring data as a persistent solution, and we don't have network. Nice. Come on, seriously? Run offline. Wait a second. Oh, I see what I'm doing. Whoop. Ah, going crazy. This run doesn't work. This one does. F it. There's some problems here. Okay, I'm not going to show that one, but usually when you run a project, thank you, network, you see that information that is coming from the manifest, and so it's good for debugging, so you put it in your log files. The next one is incremental bills. I assuming that most of you know what an incremental bill is. In case that you don't, the Gradle team has created a lot of things in order to make sure that Gradle is faster and faster and better. And one of these things is that if you keep building your artifacts, you spend a lot of time compiling, and you don't want to. What you want is to reduce the amount of time that you spend compiling. So if you can reuse previously compiled classes or resources or some other artifact, the better. What this means, using or invoking the clean task is pretty much banned. It's frowned upon. You still can have to use it from time to time, but it would be better if you don't. Because if you run a Gradle command line using the -t flag, then that will keep the Gradle daemon running with that particular task. And if any of the resources observed by that task changes, then the task is going to be invoked again and again and again. So you only pay the price of bootstrapping the JVM once and keep it warm. And again, for this, do not invoke clean, because then you lose everything and then you have to start again. Next one is who uses code coverage projects? Just in a few hands. Okay, let's see. Cobertura? Jacoco? Yeah, Jacoco is better. Jacoco gives you much better numbers. It works for simple projects, but not for multi-project builds. So here's a way for you to... There is actually a plugin, and I tried it, and it doesn't work, for generating aggregate reports for Jacoco coverage. And here's one possible solution. It's not the best one, but it does work for me. Let's say that you're going to define a list, a new dependency, where you're going to keep track of which projects need coverage. And this is just because I want to reuse variables, but you can define them later in the file. Okay, so we have a set of new properties, and then for each project that you want to configure, then you apply this. Now this can go into its own file called codecoverage.gradle if you want. And for every subproject that needs code coverage, you simply do apply from the location to that particular script. So this is just regular code coverage configuration. That's okay. What's interesting is this. First, you enable the XML report. Second, you add the current project to the list of projects that have coverage. That's the second most important thing. Then finally, on your root project, you do the aggregation. First, your root file must have evaluation depends on children. If you do not, then projects are going to be configured in whatever way Gradle considers that it should be best. But that means perhaps the root file will finish before the children. And what you want is all the children to finish setting up so that you have compiled the whole list of projects that can be covered, and then you continue. That's why we have that one. So now after that, when I invoke this thing, I have all the projects that can be covered. So with this, what I'm doing is merging all the execution data from all the different subprojects. The final thing will be to generate the report, which can be done in this way. And here, we see the usage of those additional properties that we define in the extensions block. We also have XML, and just grabbing the Jacoco test report data and the execution data and the reports for all the projects that have code coverage. It's just as simple as that. Perhaps it could be put into a different plugin, I suppose, so that people can use this way. Next one, you might have encountered this. Who compiles Java and Groovy code together? with JDK 8, running in JDK 7. Okay, lucky you, because I have to. And we encounter a problem, which is if you compile Groovy code with JDK 8, the target generated bytecode is going to be JDK 8, Java 8. But if I set on the properties in Gradle.properties, the target property, the target compatibility and the source compatibility for Java, Java will be fine. If I set it to 1.7, Java will generate 1.7. But Groovy is going to generate 1.8. Exactly. So what we ended up doing is making sure that both Java compile task and Groovy compile task know exactly which target version you want to use. And this is how we do it. We set these properties values in Gradle.properties and then target both Java compile and Groovy compile to use that particular version. So again, just one location where you define which compilation level you want to use, and then boom, it works. Next thing is you're using JDK 8, you might have seen that Javadoc now is a very pedantic tool. It complains a lot. There is a way to fix this. Write proper Javadocs, which nobody does. Or just tell Javadoc to shut up. Which is basically what we're doing is if we have found that your current version is compatible with Java 8, it's Java 8 or Gradle, and for any task that is typed with Javadoc, shut up. Don't bother me with any problems. And that's it. Yay, exactly. But sometimes what you want is to figure out if you have any compilation warnings, for example, deprecation. Sometimes the compilation task will tell you such class uses deprecated API or has some warnings, but it doesn't tell you which ones are this. And it immediately says something like run with -lint or something else, and then you try it and it doesn't work. That is because you have to do more work than just setting a flag. This is one way that you can do it. For all tasks of abstract compile, you do something like this, and then you can invoke things like that. Just define a new project property, set a value, and then call it. Now, it's a good etiquette to ask the project if it has a property before you actually use it. So that's the reason why we're calling root project has property lint instead of just saying root project.lint. Because if you do not define this, then you're going to get a property not defined, a missing property exception, right? Now, can you figure out why I'm doing this? Is there a reason to do this in Groovy? I mean, we're passing through, so that should be true, right? And if I say -p lint equals false, that should be false, right? No, you say it's not. Why? Because it's a string. So what is the value of a string whose content is the word false? It's true, exactly. So if you know that you have to rely on Boolean values, make sure they are Boolean. Don't assume Groovy Troop is going to help you on all cases. So that's why we're forcing that value to be actually transformed into Boolean. And I guess we just averted a Groovy puzzle. Finally, use plugins again. And you probably have seen, I've done this different versions of this talk called the Gradle Glam Plugins Galore, where I have shown this is the first season of plugins. There's one change right here, this is new. But basically, I would recommend you to have a look at all these plugins. They are very helpful in many cases. We have seen the license plugin versions, and if you want to have like this, calculate the number of lines of code for a particular project, just like you do in Grail's applications, you can do it with any Gradle project if you use the stats plugin. If you need to publish binaries to Bintray, there is. If you need to generate fat jars or relocate some classes inside your final artifact, then use Shadow. Generate installers that are Java-based, use ispack. Java 2 HTML, beautiful documentation based on your APIs. The Git plugin allows you to work with Git in all ways. But there's one more thing that it does, is that it has an additional setting so that you can publish to GitHub pages automatically. This is something that Jen showed us earlier today, that you can automatically push some content into the GitHub pages branch. And this is something that I extensively do with the Griffon projects. And so many other things. And Graham is here, so I'm almost done. And here's the next session, the next season of the plugins. There is versioning one. Oh, sorry, I meant to show something. It's very important now. If you work with Lombok or any other annotation processing tool, you know that we can use, in Maven we use the provided scope, which is kind of cheating because it's not the right thing. And in Gradle, since Gradle 2.13, we have compile only. Yay! But it's not the proper thing to do. You use the APT plugin, which will set the dependencies in the right scope. And this should work on all the IDEs except Gradle 3.4.1 broke IntelliJ. Yes, there is a problem in because they changed internally how they manage dependencies. I'm sorry, but this is Gradle's problem. It's not IntelliJ the one at fault here. And a few others. From here, the one that I would like to say is that if you ever need to generate WebStar files, the GNLP one is the plugin that you wish you had years ago. And if you need to talk to remote servers, there's Sugar. Did Andre? Sugar, right? Is Andre here?
No, it's not here.
Sorry. But well, the author used to be here. And you can talk to remote servers using Gradle directly on the build file. Trust me, it's really, really fun. And if you ever had the need to handle BOM properties, like in Maven, the bill of material artifact, use the dependency management plugin. So for that, I think that I'm pretty much on time. Okay. So thank you very much for listening. I again apologize for the troubles at the beginning. Completely out of my control. And hope you have some new ideas on how to improve your build files. If you have some others, I will be very happy if you can come talk to me, and I can make them part of the next version of the presentation. So thank you very much.